So good morning everyone. Please stand for the prayer. And Father is Son, the Holy Spirit, amen. And the Father is Son, the Holy Spirit, amen. Okay, please take your seats. So I say that there are no vacancies for today, which means everyone is present. Good job everyone, keep it up. So before we start our class, let me state our classroom rules. Rule number 1. Practice being on time. Rule number 2. Raise your hand if you have a question. Rule number 3. Listen attentively, of course. Rule number 4. Wait for your turn. And last rule is keep our classroom neat and clean, okay? Now, we have learned in our previous discussions that Ernest Rutherford's atomic model is mostly an empty space, correct? And the mass is concentrated in the center of the atom. We also learned that light is composed of different wavelengths and frequencies. Okay, frequency is inversely proportional, correct, to its wavelength. Now, let me have a warm-up activity first before we proceed to our next topic. You have an allotted time for this, and your timer will start now. Okay, time's up, papers up, and please return to the front. Okay, thank you. Our topic is titled The Electronic Structure of Matter. Okay, for this activity, we have the following objectives. Can you read, everyone? Okay, very good. We have to name the different models of atom. We have to give the appropriate electronic configuration of the elements and recognize the uniqueness of Schrodinger's quantum mechanical model among any other model of atom. Now, Joseph John Thomson conducted an experiment using a cathode ray tube. His experiment led to the discovery of the electron, and his atomic model is known as the nuclear model of the atom. Can you see where is J.J. Thomson's example of atomic model? That's right. The second one was his atomic model. Now, on the other hand, light is a radiant energy traveling in space through a waveform. Each radiation is characterized by a wavelength and an amplitude. So, in a wave, two successive crests or two successive troughs. Can you see, everyone? Where is the crest? Good job. The crest is in the top part of the wave. These two successive crests is the wavelength or the trough. Can you see where is the trough, everyone? That's right. The lower part is the trough. This is also a wavelength. While the amplitude is the height of the wavelength. Can you see? Can you cite where is the amplitude, everyone? That's right. This part is the amplitude. This is the height of the wave. During fireworks, we see different colors of light in the sky. It is because due to the metallic elements present in these fireworks, these elements has in contact with heat, causing it to produce different flames and colors upon approaching the night sky. So, here are examples of the elements and their flame colors when it is heated. We have zinc, the potassium, strontium, sodium, and copper. Moving on, Niels Bohr explained that each atomic spectra of elements indicates the transformation of energy within the atom. He concluded that the electrons as particles that are moving around the nucleus with fixed energy were he called as the energy level. So, for example, in this specific atom has three circles. energy levels present in that atom. The first energy level is the K, or the first energy, the 1, and the second L, the third is N, and so on. When an electron is present in this energy level and it is in ground state, it absorbs energy, causing it to jump into a higher energy level. Then, when this electron goes back to its original level, it releases energy. Now, Heisenberg's uncertainty principle states that it is not possible to determine the exact location and velocity of an electron in an orbital at the same time. So we cannot locate the exact location of these electrons, okay? But there is a probability that the electron will be in a certain region in an atom, which is called as the electron cloud. This electron cloud is also known as the region of composed negatives. So on here is an example of electron cloud. The blue part was called the electron cloud. Okay, there's a space where electrons are likely to be found. And the nucleus is the center part, of course. Moving on. Can you read, everyone? Okay, very good. The quantum mechanical model was introduced by Schrödinger. This model shows how likely an electron can be found in a nucleus. It looks like a cloud of charges having different shapes or geometrical figure. The quantum mechanical model also gives the information about the energy of the electron. It also describes the region of space around the nucleus consisting of shells. It is also called principal or main energy levels. Can you cite where is the example of Erwin Schrödinger's model, everyone? That's right. The last one was his atomic model, the yellow one. Now, for example, for the principal energy level and sublevels of the electron, the principal energy levels is composed of different sublevels containing one or more sublevels that will fit the maximum number of electrons. The number of orbitals depends on what type of sublevels are they. For S, there is only one orbital. For P, there are 3 orbitals. For D, there are 5 orbitals. And for F, there are 7 orbitals. For example, neon. Neon has an atomic number 10. Neon, Ne, has atomic number 10, which means it has also the number of electrons with us, which is 10. So we have to, in electronic configuration, we will come up with this: 1s2, 2s2, and 2p6. 6. In making electronic configuration, we have to follow this pattern. We have this arrow to connect what letter and the sublevel are we going to write next. Okay, the energy level can contain the number 8. Here are the electronic configuration of the sum of the elements and their orbital diagram. Okay, any questions, everyone? So now, let me proceed to our activity first. Our activity title is called Who Am I? So identify the following atomic model, choose the correct answer from the choices, and write your answer on a separate sheet of paper, okay? These are the choices. And here are your activity. Okay, your timer will start now. Okay, time's up. For our next activity, this is a two-part activity, everyone. Okay, first part is the match column. Column A to column B, and write your answer on your sheets. We have the same sheets to answer, okay? And the next part, write the correct electronic configuration of the following elements. The following elements, and your timer will start now. Okay, time's up. Please check your papers and pass it to the front after. Okay, I see. Does anyone have a question or suggestions for our topic, regarding our topic? I see that no one. We will have a review tomorrow. Okay, I think that's all for our topic for today. We will have a review tomorrow and a quiz, okay? Thank you everyone. That's all, and class is dismissed.